Hello everyone, my name is Jean Sanon and welcome to my Capstone Presentation titled Predicting Event Attendance for Storm Entertainment. In this project, I use data analytics to understand what drives attendance at storm events and to develop a predictive model that helps improve planning and audience turnout. Storm Entertainment organizes Afro-Caribbean cultural events, but attendance often varies from one event to another. Some events attract large crowds, while others with similar promotion and pricing don't. The purpose of this project was to identify the main factors that influence attendance and build a model that predicts turnout more accurately. In short, this project asks what drives attendance? The venue, the ticket price, or the type of event? To reach this goal, I focus on three main objectives. First, to identify the major predictors of event attendance. Second, to use data analytics to guide pricing and venue decisions. And finally, to improve marketing strategies based on predictive insights. Each of these objectives supports Storm's missions to plan events more efficiently and attract larger audiences. Before building the predictive model, I look at research that explored what drives participation and engagement. For example, previous studies showed that ticket pricing can shape how people perceive event quality, even when demand doesn't change much. Others found that factors like season and weather play an important role in participation, meaning timing and context really matter. And research on marketing showed that strong visuals like good photos and videos help attract and engage audiences. Together, these insights guide how I approach predicting attendance for Storm's event. For this project, I use three main data sources. First, Eventbrite exports from 16 storm events held between 2017 and 2025. Second, survey responses from 24 participants, which provide insight on demographic and motivations. And third, weather data for each event, which help capture seasonal patterns that might influence attendance. Altogether, these datasets created the foundation for predicting event turnout. Once the data was collected, I prepared it for analysis. I started by cleaning and coding the data to make sure it was consistent and ready for modeling. Then I performed exploratory data analysis using charts and statistics to spot early trend. Finally, I applied a multiple linear regression model to test which factors had the strongest impact on attendance. The key variables include ticket price, venue quality, event type, promotion method, weather, and attendance. Together, these techniques help transfer raw event data into clear, predictive insight for Storm. Before building the predictive model, I first collected and merged all Eventbrite records from 16 storm events held between 2017 and 2025. I then cleaned and numerically coded the data, including creating dummy variables to prepare it for regression analysis. I also created an adjusted attendance variable to include dull cells so each event's turnout was represented more accurately. Finally, I verified the dataset for consistency and accuracy before moving on to analysis. Before running the model, I explored the data to understand what might explain attendance differences. The exploration showed three key things. Attendance varied widely across events, from 12 to 189 guests. Premium venues drew almost twice as many people as standard one, and higher ticket prices were linked with slightly higher turnout, suggesting people associate price with quality. Let's look at each of these patterns more closely in the next few slides. This histogram shows how attendance was distributed across all 16 events. Most events had fewer than 75 guests, while only a few reached above 130. So we can see that attendance varied widely, a sign that some events performed far better than others. Here we're comparing average attendance between standard and premium venues. We can see that premium venues drew almost twice as many guests on average. This clearly suggests that venue quality has a strong influence on turnout. Finally, this scatter plot look at ticket price and attendance. The points show a moderate upward trend. As price increase slightly, attendance also tend to rise. That tells us ticket price may signal event quality rather than discourage participation. The regression model explains about 43% of the variation in attendance. Venue quality emerged as the strongest predictor, followed by ticket price. This means events held in premium venues consistently drew higher turnout, and slightly higher prices were linked with better perceived value. Other factors such as event type or weather were explored earlier but not included in the final model due to limited data. Based on this result, here are my key recommendations. Focus on premium venues. They consistently generate higher turnout and improve overall audience experience. Use tiered pricing. Slightly higher prices can signal event quality and boost perceived value. Continue collecting event data. Expanding the dataset will improve prediction accuracy and help optimize future planning. Together, these actions will make Storm's event strategy more data-driven and efficient. For the next stage, I recommend expanding this predictive model in three ways. First, integrate more survey data to capture audience motivations and demographics. Second, test new predictors such as promotion type, including visuals, artist recognition, and seasonality to refine predictions. And third, automate data collection and develop an interactive dashboard to track attendance trends in real time. This enhancement will make the model smarter and more practical for ongoing event planning. These are the main sources that inform this project, covering event pricing, participation factors, data quality, and effective storytelling with data. They provided the foundation for the predictive methods and insight applied to Storm Entertainment. This concludes my presentation on predicting event attendance for Storm Entertainment. Thank you for your time and interest in how data can help Storm make smarter, more impactful event decisions. I look forward to reading your comments and feedback.